Hi everyone, welcome to In the Mix. In this video, we're going to cover Motu's MIDI Express XT, which is a very powerful and flexible MIDI interface, Patchbay, merger, and synchronizer, all in one rack space unit. This video is primarily focused on the MIDI features of the XT, but you might also find it useful for the Micro series as well. Let's get started. Motu MIDI Express XT features 8 independent MIDI inputs and outputs. It's compatible with Clockworks software, which can be used for routing, merging, and changing various settings. Computer requirements for the latest version are OS X 10.6 or later for Mac and Windows 7, 8, or 10 for PC. In addition to MIDI sequencers, it can also function as a standalone MIDI interface as well. It also supports all SMPTE frame formats, including 24, 25, 2997, drop and non-drop, and 30 FPS. This unit has an internal international built-in power supply. It comes with a power cord, USB cable, a CD with software drivers, user manual, and the product registration card. The MIDI interface connects to the computer with the supplied USB Type A to Type B cable. This allows the computer to communicate with all MIDI devices that are connected to the MIDI interface. The Type A plugs into a USB jack on the computer, and the square Type B plugs into the interface. The only thing that I'd like to mention is that initially I had plugged it into a USB 3 port and I was experiencing all kinds of strange issues. As soon as I switched to a USB 2 port, everything seemed to be working just fine. Aside from this, once the driver is installed, it's just a matter of plugging the MIDI devices to the unit. For instruments that require a two-way communication setup, we should connect the MIDI out on the device to the MIDI in on the MIDI interface, and also the MIDI out on the MIDI interface to the MIDI in on the instrument. This way, the MIDI device will be able to send and receive MIDI data. We don't have to use the same numbered MIDI in and MIDI out for each device, as the MIDI Express XT is pretty flexible and treats each jack as an independent input and output. In this setup, I have a core keyboard plugged into a MIDI input 7 and output 1. This will work, but it's best to keep the inputs and outputs consistent, because once you start adding more and more instruments, it'll be much easier to work with an organized setup. Then we have MIDI devices that only need a one-way MIDI connection. For devices that are strictly used as MIDI controllers and do not need to receive MIDI data, we can just connect their MIDI out to the MIDI in on the interface. For sound modules or other devices that are used as receivers and don't need to transmit MIDI data, we can go ahead and connect their MIDI in to the MIDI out on the interface. Now let's talk about the MIDI connectors. MIDI Express XT is an 8x8 MIDI interface. On the rear panel, we have 7 MIDI ins, 8 MIDI outs, and on the front panel for easy access, we have one pair of MIDI in, MIDI out. So this unit features a total of 17 5-pin MIDI connectors. Both MIDI out number 8 jacks on the front and rear panel mirror each other and send out the same exact data. Using one does not disable the other, so they can be used simultaneously. If all MIDI ins and outs are used up and there's still more gears to connect, we can try using the MIDI through jack on the instruments that are directly connected to the MIDI interface and daisy chain additional instruments that way. This is not always a perfect solution, as not all MIDI devices have a through port. Also with this method, all instruments in the chain share the same MIDI out port on the MIDI interface, which means they also share the same set of 16 MIDI channels. In this setup, all instruments in the chain will play at once because data sent to the first unit will be received by all the devices in the daisy chain. If this is not what you want, then you would have to program each individual instrument in the chain so that they would only respond to a particular MIDI channel. For a large collection of MIDI devices, a better solution would be to connect multiple MIDI interfaces to the computer. With Motu MIDI interfaces, we can mix and match up to 10 or more and connect them all to the same computer using a USB hub. If you add more MIDI instruments to your setup, you can expand your current system by adding more Motu MIDI interfaces, and your original investment doesn't go to waste. This is not a SMPTE tutorial, so I won't get into details, but for those who are not familiar with this topic, I'll make a quick and simple introduction. Due to differences in mechanical design, voltage fluctuations, and many other factors, physical analog devices have a difficult time maintaining the same relative playback speed and position over the course of a program. They simply cannot stay in sync without some kind of timing lock. To address this issue, the Society of Motion Picture and Television Engineers developed the standard method of interlocking audio, video, and film, which is known as SMPTE timecode. Timecode recorded onto an analog audio or video cue track is known as longitudinal timecode, otherwise known as LTC. In order to have a synced performance between multiple audio, video, and film analog playback systems, it's necessary to have a synchronizer. The main function of a synchronizer is to control the speed and relative position of slave machines using the speed and relative position of a master device. Okay, so you're probably asking, what does any of this have anything to do with this MIDI interface? Well, MIDI Express XT is a MIDI interface, but it can also read and write all SMPTE frame formats. As a converter, it can read incoming SMPTE timecode from an analog source such as multitrack recorder and convert it into MIDI timecode or MTC. Then it can send that timecode information to a destination such as a software sequencer. In other words, the machine can be synchronized to a DAW with this MIDI interface acting as a synchronizer. As a generator, it produces both LTC and MTC timecode, either running under its own internal clock or while slave to external timecode. Let me give you an example for making the connections. I want to synchronize a digital console with an analog multitrack recorder as a SMPTE timecode source, so the digital console is designated as slave and the tape machine as master. There's a SMPTE input and output on the rear panel of the Motu Midi Express XT. Using a shielded 1/4-inch audio cable, the audio out or the SMPTE out of the tape machine should be connected to the SMPTE in of the MIDI interface. And then the SMPTE out should be connected to the audio in or SMPTE input of the slave device, which in this case is a digital console. Motu Midi Express XT requires Mac or PC drivers and a setup program called Clockworks, which gives access to the MIDI interface features. The CD that comes with the package includes the installers for all this. However, it's best to download the latest installers from the official website. There you'll also find additional installers for older hardware. Here I have the user manual, Motu software installer for Windows, and the firmware update folder. The software installer will install the drivers and Clockworks software. I've already connected the MIDI interface to the computer with the supplied USB cable. Motu suggests that we first turn on the computer and then turn on the MIDI interface. The MIDI interface is turned on. I'll go ahead and install the software. If you get the Windows Add Hardware wizard during install, just exit from it. I'm fast forwarding the screen here, and it's done. Drivers are installed. And here's the Clockworks software. To update the firmware, press and hold the stripe button on the front panel and turn on the unit. This will put it in the firmware update mode. Then just run the firmware update installer and that'll update the unit. If you own an older hardware, be sure to check the serial number on Motu's website to see if it's compatible with the latest firmware. Of course, there's also an installer available for Mac computers. Just click on the installer and follow the on-screen instructions. Just like Windows, this would also install the drivers and Clockworks software as well. After restarting the computer, we can go to the Audio MIDI Setup utility and add Motu as a new external device. Then drag on its input and output arrows to make the MIDI port configuration. If for any reason the Motu interface does not appear or is grayed out, double-check the cable connections and click Rescan MIDI. Double-click the new instrument if you want to give it a descriptive name and make any custom changes to the settings. Once you quit the window, all settings will be saved as default configuration. Once the software installation and setup process for the Motu Midi interface is completed, all MIDI inputs and outputs will become available for the MIDI sequencer software. This is Pro Tools, which is my primary DAW. Let's check out the new added Motu MIDI in and MIDI out ports that can be accessed from within Pro Tools. Here I have 8 MIDI input ports and 8 MIDI output ports that correspond with MIDI ins and outs 1 through 8 on the MIDI interface, and there's 16 MIDI channels available for each port. In addition to 8 MIDI ins and outs, there's also a sync in out all port available that can be selected as an input and output for the MIDI track. This port is labeled as all cables for Mac computers. Sync in out all or all cables port serves a different purpose as an input than it does as an output. As an input, it is used for receiving all sync info to the DAW from any input on the device. As an output, it sends MIDI data to all 8 outputs of the MIDI interface simultaneously. The default factory settings allow the MIDI sequencers to access any of the input and output ports on the MIDI interface, so with this setup, we don't even have to run the Clockworks application in the background. However, we can use this program to change the synchronization settings, cable routing, filtering MIDI data, and various features of the MIDI interface. Let's start from the top. Under the File menu, there's a list of options available. At the top, we can see the list of Motu Midi devices that are successfully connected to the computer. I only have one MIDI Express XT, which is already selected. If you have more MIDI devices available, they're all going to show up here. Once you make a new selection from the list, a new window is going to open for that particular device. With the Save and Load configuration command, we can save the current Clockworks custom settings as a document on disk and recall the settings by loading that document later on. There's supposed to be a two-way communication between Clockworks and the hardware. Changes and selections on one should instantly reflect and update the other. If the changes that you make in Clockworks do not accurately show in the hardware, then we can select Refresh and Clockworks will be updated to reflect the most current state of the hardware. Reset to Factory Settings resets all the changes and restores the factory default settings in the MIDI interface. Configure Digital Timepiece refers to the Motu Digital Timepiece interface, which is an audio synchronizer. If you have this particular hardware in your setup, you can use this option to configure the settings. If any of the connected MIDI devices do not appear in the window menu here, Rescan will scan the USB ports and will find the MIDI devices. Under the Routing tab, we can see the inputs and outputs for the MIDI interface that is currently selected. Here we can manage the signal flow between all MIDI devices that are connected to the Motu Midi interface. This particular routing system is a factory preset. I'll go ahead and choose an empty user preset so the cable routing features will be more obvious. To make a connection between the source and destination, we can just click on the source icon on the left and drag it to the destination icon to the right. It's possible to connect one input to multiple outputs. We can either do one by one manually, or shift drag from the input to the first output and then to each additional output to the right. By default, all the inputs and outputs are already connected to the computer, so there's no need to make additional connections to the computer. In fact, Clockworks wouldn't even let us do that. Clicking on the input or output icon highlights and selects the connection. Clicking on an input or output with multiple connections selects all cables associated with that input or output. Clicking anywhere in the space between the input-output columns deselects all connections. To break a connection, just select one or multiple cables and press the delete key. For the MTC connection, if the Motu interface is to be used as a master timecode generator, we would connect the MTC port to the MIDI out connection where the slave MIDI device is connected. To slave the Motu interface to MIDI timecode coming from an external device, we would connect the output of the device to the MTC port. For routing MTC to the computer port, we don't have to make manual connections because again, there's always a permanent internal connection from all ports to the computer already. The same thing goes with the MMC ports as well. The Motu interface can be used either as slave or master. Under the Preset tab, there are 8 factory and 8 user presets available. Factory presets are hardwired and cannot be overwritten. However, we can modify and save them as user presets, which are stored in the hardware itself. The bank button on the front panel selects the factory or user preset bank. The preset button cycles through the presets. The selected item will become lit. The factory presets provide various settings for the most common situations. Let's briefly go over all 8 presets. Sequencer 30 and 25 FPS have different frame times but are identical otherwise. This preset is designed for MIDI sequencers and DAWs that support multi-cable interfaces. Live Keyboards preset is useful if you want to route any external MIDI controller connected to a MIDI in to all MIDI outputs. For example, use this preset to route a MIDI controller to sound module without using the computer. If the controller is communicating both ways with the MIDI interface, make sure to match the input-output MIDI port numbers on the interface to avoid MIDI feedback loops. Dual split is similar to live keyboards, except it splits the interface into 2 sets of inputs and outputs. Input 1 is routed to outputs 1 through 4, and input 5 is routed to outputs 5 through 8. This is useful if you don't want to set an input to all outputs. With Merge All, any device connected to a MIDI in will send data to all devices connected to the MIDI interface, including the computer. Because any incoming data is sent to all outputs, this preset is great for troubleshooting. If you want to make sure all of the devices connected to the MIDI out of the interface are functional, you can use this preset to see if they all respond to incoming MIDI data without having to worry about MIDI routing. The Merge Sum preset is similar to Merge All, except it divides the inputs into 2 groups. Inputs 1 through 4 are routed to the computer only, while inputs 5 through 8 are routed to all outputs but not the computer. Under the Muting tab, there is an advanced MIDI data filter that we can use to filter any type of MIDI data that is sent and received by each MIDI in and MIDI out port. Here, from the drop-down menu, we can choose the type of data that we want to filter or remove from the MIDI signal. And from the cable menu, we can select the input or output that we would like to apply this filter to. We also have cables 1 through 8 that represent 8 MIDI ins and 8 MIDI outs on the MIDI interface. Each square or checkbox is basically a MIDI channel that can be selected and have its own independent muting status within each port. Let me give you an example. I have a MIDI device plugged into input-output 1 of the MIDI interface. I'll go ahead and assign the output of this MIDI track to port 1 channel 2. This track has some notes and 2 program change events. Let's check it out. This time I'll filter pad change for port 1 channel 2. If I play back the MIDI track, the MIDI device will receive the notes but not the program change messages. Set All applies the selected data to all cables on all 16 channels, and Clear does the opposite. The Mapping tab controls the channel mapping or rechannelization of MIDI data on all MIDI in and MIDI out cables. Basically, we can use this convenient matrix here to reroute the MIDI signal to a different channel as it enters or exits the MIDI in and MIDI out ports. Suppose we're recording a MIDI sequence from an older keyboard that transmits all data over one channel only. This means all individual tracks will be recorded into one single track. With the rechannelization feature, we can take data input on one channel and transmit it to the sequencer on any other channel. This way, data can be recorded to separate tracks. We can also use this feature to do exactly the opposite. For example, there are sound modules that offer combi-layered patches that are assigned to one MIDI channel. If we wanted to use the data on multiple tracks to trigger this combi patch, we can simply rechannelize them to a single channel. There's a chart in the manual that shows how muting and remapping interact with each other. On the MIDI import, muting occurs before channel mapping, so if I mute the data on channels 1 through 4, and rechannelize all 16 channels to channel 16, only channels 5 through 16 will get remapped. On the MIDI output, muting occurs after channel mapping. So if I mute channels 1 through 4 and rechannelize all channels to channel 16, all 1 through 16 channels will get remapped because the data is already switched to channel 16 before it goes to muted channel 1 through 4. Sync tab controls the MIDI interface's sync and MMC transport control features. Here at the top, we have the transport controls. If set to internal mode, these buttons control the timecode generated by the Motu interface. The standard SMPTE readout shows the current frame locations in hours, minutes, seconds, and frames. It displays the running update of the timecode being generated or converted by the interface. We can also type in the frame location manually to cue the interface to a specific frame location. Right under the SMPTE readout, we have 8 locate buttons that can be used to cue the interface to a particular frame location. These buttons are only available if the clock mode is set to internal. To set a locate point, just set the SMPTE counter to the desired location and then shift-click the locate button. Here from the drop-down menu, we can select the clock mode and the supported frame rates. With clock set to internal, the interface ignores incoming timecode. MTC allows the interface to sync to incoming MIDI timecode from other devices. Both LTC and LTC Quick Lock allows the interface to sync to SMPTE timecode received on its SMPTE input jack. LTC mode offers additional features. It transmits regenerated LTC through the SMPTE out jack and measures the incoming timecode with an extremely accurate internal clock, and it displays the results in the SMPTE reader window. Because of all these additional features, it takes longer to establish lockup to incoming timecode than LTC Quick Lock mode. Here on the left, we have the status section. There are 5 status indicators that can be illuminated depending on the status of the interface as a synchronizer. There are 3 checkboxes under the status section. Frame lock option is only available if the interface is locking to external SMPTE timecode. Sometimes the master device that is outputting the SMPTE timecode is not able to generate continuous and consistent frame times as the frame locations jump around to different times. If the frame lock option is checked or turned on, and the interface detects more than 5 frames in a row that are not continuous with respect to previous frames received, it will stop converting altogether. With this option unchecked or turned off, the interface will ignore inconsistent incoming timecode without glitching or stopping. In this mode, it will keep converting an uninterrupted stream of continuous timecode based on the information to which it first locked. Certain devices keep generating timecode even if they're paused and parked on a single frame. When locked to such devices and generate signal when stopped option is checked, the interface will keep outputting timecode. If you want to set the frame rate manually, then uncheck Auto Detect Input Frame Rate option. Check the box if you want the interface to automatically detect the frame rate of incoming timecode. To the right of the status section, we have some more parameters. LTC output slider adjusts the overall gain of the timecode from the Motu interface LTC output jack. Moving the slider to the left decreases and moving to the right increases the level for LTC output in all sync modes. Still frame sensitivity option controls the number of frames in a row the interface needs to receive to consider incoming SMPTE as being paused or parked on a single frame. Lower values make the interface more sensitive and responsive. Raise the slider if it's misinterpreting various transport functions such as shuttling. Generally, when there's a dropout in the flow of timecode, the synchronizer would automatically assume that the source timecode generator has completely stopped. The freewheel option drop-down menu here lets us select how many frames can drop out before the Motu interface decides the machine that it is locked to has gone offline. The default value is set to 4 frames. This means during the dropout, Motu will continue generating timecode for the next 4 frames at the same rate as before the dropout. If the source comes back before the selected number of frames is up, nobody would even notice there were missing frames and they will keep playing in sync like nothing ever happened. If Motu does not receive any more timecode after 4 frames, then it will stop converting. It's best to set the freewheel boundary to a middle ground that prevents undue stopping because of occasional dropouts and yet doesn't take a long time to stop after the stop button on the source is intentionally pressed. With freewheel set to 0 frames, Motu will begin generating timecode on its own as soon as it stops receiving incoming timecode. In that case, you would either have to change the freewheel frames to a bigger number or use the stripe button on the front panel to stop. The factory default MIDI machine ID for this device is 19. The only time that we would need to change the ID number is if we had another device with the same exact ID. Then we have this option here to change the ID to a number that is not being used by another device. Under the pedal tab, we can program the pedal input on the front panel of the Motu interface. We can just use a standard foot pedal. There's 2 options available, off and normal. With normal selected, there are some standard pedal options available. Here we have the negative and positive polarity, the type of MIDI data that the pedal can generate, and the MIDI channel that is going to be assigned to the selected MIDI message. For more advanced routing, we can go to the Routing tab and make the necessary connections. I hope you found this video useful. If you'd like for us to cover a specific MIDI-related topic, or if you have any questions or comments, please feel free to share your thoughts down below in the comment section. See you next time!